Alright, good morning, good afternoon, good whichever time you may be listening to this. Let us talk about, say, the semester exam, spring review part 1. I will be adding things into your formula sheet as I can, and we will cover as many of these questions as we can in this first video. So the first thing we want to look at is we're going to talk about trigonometric functions. So the idea here would be this. You have basic trigonometry, you have sine, cosine, and tangent. Sine theta is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. Theta is a degree measure. So when you're looking at a triangle and you're saying this is a right triangle, you have, say, a degree. The one that's the opposite is the one you could draw an arrow to. The adjacent one is the one that's connected to the angle, and the hypotenuse you should be able to tell. But using these right here is going to help you find the missing sides. Now, I would point out that you're going to put numbers in these 3 slots. There's 3 slots you're putting numbers in. 2 out of those 3 are going to have numbers, and the third one will be your x. Okay, so when you look at something like number 1, and you see here that you've got, say, something like 44 degrees, 90, and they want you to find JK. JK is this right here, and that's your missing side, so that's x, which is the opposite of the 44 degrees. The 90 is a hypotenuse, and you can see there's an adjacent. So if I set this up, it would be sine, because I'm dealing with opposite and hypotenuse, sine 44 is equal to x over 90. The opposite, which is x, the 90, which is the hypotenuse. How do you get rid of this? Every single time you have a 90 degrees, or a number under, not 90 degrees, but a number under the bottom, the denominator, you can multiply to get rid of it. So that would end up giving me something like 90 sine 44 gives me x, and if you type that into the calculator, you're going to get 62.5. Round to the nearest whole number, I guess. Dang nab, I did not read. I got to start reading these better. Would be 63 degrees. Oh, I'm sorry, not 63 degrees, just 63 units. All right. So that would be that, and you would kind of, that, like again, it's very simple to set up. The next one talks about how high is this ramp. So to the nearest foot. Again, we're doing whole numbers because apparently it's too hard for y'all to think about decimals. So we have here, again, opposite, and now we have an adjacent. So we're going to use tangent. 22 is equal to the x over 32. And again, same thing, multiply. Every time you've got that number here on the bottom, if you multiply it to the one there, you're going to get your answer. And we've got that easy. Type it into the calculator and go from there. And again, remember, you have to have the calculator in degrees. So remember how to change it into degrees. Okay? And that one will give you 12.9, or in this case, if you round that off to the nearest foot, 13. Whatever. Okie dokie. Next one, same thing, same idea. There you go. Here again is the opposite and an adjacent. So keep in mind that they're basically the same thing. We're dealing with tangent. 76 degrees is equal to x over 12. So that means I would type into the calculator 12 times tangent 76 to get approximately 48.1, which according to this, to the nearest foot, would just be 48. There you go. Number 4, elevation and depression. Okay, keep in mind, fairly simple question. You should not be missing this type of question. Look at a horizontal line. Find the horizontal line that connects the angle. If it goes up, it's an elevation. If it goes down, it's a depression. So when you look at number 4 and look at angle 3, you should be able to see that there is this horizontal line right here. Whoops, wrong button. Let's try that again. This horizontal line right here goes from that horizontal line to the angle, it goes up. So that would be an elevation. And you would take note that angle 1 is a depression. So you might want to make note that 1 is a depression and 2 is an elevation. I'm sorry, 3 is an elevation. 2, because it's not really next to a horizontal line, we're not going to worry about being an angle of elevation or depression. Okay, the next part, if you're missing a degree, you would use inverse. And again, to find those functions, you go to trig on the calculator. That's the button next to the 7. Okay, so here I've got sine inverse, cosine inverse. I went too far. Cosine inverse and tangent inverse. Again, notice the same thing, but the difference is when you put those in, it's going to help you find a degree. So if you look at number 5, and you got this 9.6 and 2, here's theta. They want angle A. So there's theta. So 9.6 is going to be the opposite, where 7.2 is going to be the adjacent. So then I could say that's opposite and adjacent. So that's tangent. 9.6, tangent inverse, 9.6 over 7.2. Press enter, and it would tell you 53 degrees. Okay, so that one would be 53 degrees. All right, let's look at number 6. 6, they tell you the angle of depression is 34 degrees. So that puts 34 right here. And the pilot reports that the plane's altitude is 3,200 feet. How far is it to the airport? Well, keep in mind, opposite angles are congruent. So this 34, then that's 34. So now this is the opposite, and I want this. So now I've got tangent 34 degrees is equal to the opposite 3,200 over the adjacent. So now this one is like this, where I got to have 3,200 and the adjacent. So what happens here? When the x is on the bottom, guys, these two switch. And these are things I would remind myself on the calculator how I can do this, and maybe make note of that on the like the formula sheet, that I can make sure if the x on the bottom, I switch them, and if it's the x on top, I can just multiply. So anyways, now x is equal to 3,200 divided by tangent 34. Okay, so if you go back to there and say 3,200 divided by tangent 34, you should get about 4,000 to the nearest foot, 4,744 feet. Okay, and that's it. Fairly simple, not a problem. Number 7 talks about law of sines and cosines. We did not cover that. That was covered in the pre-AP classes, so we will omit that one. If that ends up on the test, make note of it, and I will just give you credit for that one and give you bonus points for that. Okay, so next one, we're going to find BC to the nearest whole number. I take that back. Apparently this one is also dealing with law of sines and cosines as I double check it. So this one we are going to omit also. Again, that was stuff that was covered in the pre-AP classes, not this class, so we're not going to worry about that. Alright, so let's look at number 9. Name a polygon by the number of sides and tell whether it's regular or irregular. Okay, so again, on like number 9, when you look at that, and again, regular means all sides equal. So that's something you can make note of on your thing, or all sides congruent. Irregular obviously isn't. So not all sides congruent. So you can go with that right there, and go with that. So, and then name the polygon by its number of sides. So let's keep in mind, like obviously 3 sides. 3 sides is a triangle. 4 sides, no matter what, is a quadrilateral. And you can build that up through, say, 10 to 12 sides. Okay? So build that through, say, 10 to 12 sides. Do that on your own for your paper. So on number 9, I would say here I've got 1, 2, 3, 4, 5, 6. I have 6 sides, which means it is a hexagon. And I would say it's irregular because not all sides we can verify are equal, so this would be an irregular hexagon. Okay, number 10, find the measure of each interior angle for a regular octagon. So, to find the measure, and let's do this here. I'm going to give you kind of an idea here. There's actually 3 ways we can ask this question. One, we can ask about each interior, sum of the interior, actually some should have been first, and each exterior. Okay, when you have like the sum of the interiors, it is basically n minus 2 times 180. Okay, so the number of sides minus 2 times 180. For each, when they use the word each interior, is that n minus 2 times 180 divided by n. Okay, so keep that in mind. Again, n is the number of sides here, so you might want to make note of that. N is number of sides. Okay, and then each exterior angle, if I want to do that one, is just 360 because all exterior angles always add up to 360 no matter how many sides divided by the number of sides. Okay, so that one should be fairly easy. So like if you wanted to find the measures of the interior angles on number 10, you would be using that first formula where I would say, okay, regular octagon, that's 8 sides. So I would say 8 minus 2 times the 180, and then I would divide that by 8. Okay, so that would be, so for a regular octagon, because they're all divided up equally. So again, I would hit Control Divide here and say 8 minus 2. Type this in, basically type this in like the way I see, you see it on the like right here on the screen. Again, Control Divide to get this fraction, so you can type this in all at once. And when you type it in, you get 135 degrees. An easy peasy type of question. All right. Number 11, we want the exterior angles of a convex pentagon. Again, remember, exterior angles, the sum is always equal to 360 degrees. Always. So I can say here 18x plus 12 plus 16x plus the 8x plus 6 plus the 10x minus 12 plus the 5x plus 12 equals 360 degrees. Wow, I ran out of space there. Now, you could type all that in, figure it all out. Obviously, this one right here should be the biggest one, but you're trying to find x real quick. So, again, you could combine all your like terms. You would end up with 57x plus 18, subtract 18, divide by 57, and you would end up with x equals 6. You would still need to put that back here and say 18 times 6, and then add 12 to that to get 120 degrees. So that this one right here, the largest angle, would be 120 degrees. Now, I would tell you this. Keep in mind that there would probably be an answer choice that would say x equals 6, but you would still need to find that and go back to that. Now, if you don't think you can handle solving this type of equation, keep in mind, we now know we can go to the numerical solve. So if you're in the calculator page, all you got to do is type menu 3.1, and you would type in this equation, menu 3.1, type in this equation, and then again, don't forget the comma x at the end to make sure you know that it's solving for x. Press enter, and it will tell you x equals 6. But even then, you would still need to make sure you know to put that back in here and say 18 times 6 plus 12. Okay, so let's look at this and kind of keep going. Okay, on something like this, here's something you might want to add on your thing, or you just know this. When you're talking about a parallelogram, okay, parallelograms, we can adhere to the formula sheet. Opposite sides would be parallel. Well, not only are they parallel, they're going to be congruent. That's going to be important. Also, when you look at diagonals, those are congruent. Like the pieces that are divided up are congruent. So because of that, I can say here like 5x minus 5 equals 3x. That's supposed to be a plus 9, I think. And solve that. And that would give me x equals, let's see here, 7. Again, we can talk about how you would get that answer. But keep in mind, they're saying find AB. So you need to put this back here and say 7 times 5. So here, AB is equal to 7 times 5, which is 35, minus 5. So AB is 30. So you got to put the 7 back in place of the x. Also, you can say here 7y minus 10 is equal to 5y. And again, we can do the numerical solve. And in this case, because it's a y, you could say type this in and say comma y, and it should still solve it. Either way, you should get y is equal to 2, but we want to find bx. So I could put the 2 here and say 7 times 2 is 14 minus 10 is 4. 1 second. Well, I guess that's why I had to check myself. I was like going, wait a sec, that's not 2. It should have been 5. That's what I get for trying to do it all in my head at the same time. Whoops. Okay, so that should have been 5. And then if I put that in there, I get 7 minus 5, which is 35, minus 10. So this one right here, bx, is equal to 25. Okay, and that's really about it. Obviously, if this is 25, so is this. I mean, keep little things like that in mind, and that should be easy. Now, how is that different here for like number 13? On number 13, okay, I would make note on something like this, on a parallelogram, like angles like this that are like, say, across from each other, they add up to 180. Opposite angles are congruent. Okay, so kind of keep that in mind. So that means here, these two add up to 180. So I could say here 16x minus 2, I think that says minus 2, yes, plus 8x plus 14 equals 180. Now, if if you don't remember, use the numerical solve, but this would be 24x plus 12 equals 180. So basically here, when I solve for x, I would end up again with x equals to 7, and again I would have to put that here and say 8 times 7 plus 14 equals 70 degrees. So angle E here is 70 degrees. So keep that in mind. We're noticing a lot of resubstituting back in. Okay, so show that angle JKLM is a parallelogram for x equals 7 and y equals 14. So what does that mean? Well, again, these two have to add up to 180. These two, and then these two should be congruent. Okay, so if I put 7 here, I get 7 times 7 is 49. 49 minus 4 would be, so angle K is 49 minus 4, 45 degrees. Okay, if I put the 14 here, I got that's 140 minus 13. I think that's a minus. That's hard to see. Yeah, I'm going to say that's a minus. So that's 140 minus 13, so that's 127. So angle L is 127. You know what? Actually, that's a plus 4. I hate when bad copies are done like that. So this right here should have been 49. I'll just erase this like this. Okay, so it should have been 49 plus 4, which would have been 53 degrees, and this one's 127. So if you add those up, that's 180. So that checks off right there. The ones consecutive or next to each other are add up to 180. Then if you put the 14 over here, you got 9 times 14, which is 126, plus 1 is 127. So angle J is 127, which means these two are congruent, which is what I want. So that checks off that. So this is a parallelogram because these two are add up to 180, and these two are congruent. Okay, so that's something you might want to add, that knowing that opposite angles are congruent and consecutive angles next to each other, are add up to 180. Supplementary. Okay, so I'm at 18 minutes right now. I'm going to go ahead and stop there. I don't know, I've only got through 14 problems, but we'll continue at problem number 15 and see if we can go a little bit faster, or we'll see. I mean, I'd rather make sure I explain well and have to do more videos than not explain at all. So that's it for today. Thank you so much for your time. Again, guys, if y'all have questions, make sure to ask in class, because that's the way I can help y'all. So let's talk about it and let's do this. Thank you so much. Y'all take care.